Welcome to my YouTube channel. In this video we are gonna continue with our previous paper what we were doing, W19 question paper 11. So question number 9, here we can see a curve is given and it passes through the point 2 3. So it says find the equation of the curve. So we know the first derivative is given to us, so we can use integration. So dy by dx is equal to integral 5x minus 1 to the power half dx minus 2 times integral of dx. So y is equal to 5x minus 1 to the power of 3 by 2 over 3 by 2 times by 5 minus 2x plus c. So here we use the formula which is like ax plus b to the power n dx. So at that time we have ax plus b to the power of n minus 1 over a times n minus 1. So from here this equation will become 2 times 5x minus 1 to the power 3 by 2 over 15 minus 2x plus c. Now we have coordinates 2 and 3, so we can plug over here. So 2 times 10 minus 1 is 9. So 3 plus 4 is 7, and then here we will get 18 by 5 plus c. So c will be equal to 17 by 5. So now the equation will become 2 times 5x minus 1 to the power of 3 by 2 over 15 minus 2x plus 17 by 5. Then in the second part it says find d square y over dx squared. So since we know dy by dx is given, which is 5x minus 1 to the power 1 by 2 minus 2. So if we're going to find the second derivative of this, so we need to apply the power rule. So this will be the power rule, and then derivative of negative 2 will be 0. So d square y over dx squared is equal to 5 over 2 square root of 5x minus 1. Then in the next part of it, it says find the coordinates of the stationary point on the curve, and showing all necessary working determine the nature of the stationary point. So since you remember, to find the stationary point we need to set first derivative equal to 0. So first derivative was 5x minus 1 to the power half minus 2 is equal to 0. So 5x minus 1 to the power half is equal to 2. So 5x minus 1 is equal to 4. So from here we will get the value of x, which is 1. Now we need to put this to check the nature. So we need to put this value into our second derivative. So when x is equal to 1, d square y over dx squared at this point, which is so 5 minus 1. So that's mean if we simplify this, so this is d square y over dx squared over 5 times 5 over 2, and then 5 minus 1 is 4, square root 4 is 2. So this is 5 over 4, and this is greater than 0. So if it is greater than 0, so that's mean it's minimum. Okay, we're done with this. Then we're not gonna do vectors that are not anymore part of AS. Let's have a look on this question. So in this question, the diagram shows a shaded region. So we are given an equation of a curve, so which is x squared plus 4x plus 3, for which x is greater than or equal to minus 2. So in the first part it says express this in the form of y is equal to x plus a whole square plus b. So we need to use completing the square. So while we are using completing the square, we need to check the coefficient of x squared is 1. If it is 1, we need to get the coefficient of x, divide that by 2 and square it. So we need to add and subtract 4 to complete the square. So y is equal to x plus 2 whole square minus 1. So now we wrote y is in the form of y is equal to x plus a whole square plus. So then it says hence for x greater than or equal to minus 2, express x in terms of y. So that's mean y plus 1 is equal to x plus 2 whole square. So x plus 2 whole square is equal to y plus 1. So x plus 2 is equal to plus minus square root of y plus 1. And from here we can take only the positive part of it, so which is square root of y plus 1. So now we can look to the next part of it. It says hence showing all necessary working, find the volume obtained when the shaded region is rotated through 360 about the y-axis. So now the volume along y-axis will be I times integral a to b. So here we have x square dx. So this is x squared dy when it's a volume around the y-axis. So vy is equal to pi, and the limits we know from -1 to 3. X we just found, which is 2 plus square root of y minus 1 minus 2 plus square root of y plus 1 whole square dy. Double check. Yeah, minus 2 plus square root of y plus 1. So now here, further to this, we have to initially simplify the inside. So if we simplify the inside, so this is what minus 2 square is 4 minus 2 root y plus 1 and then plus y plus 1 dy. So now minus 1 to 3, so this is 5 plus y minus 2 root of y plus 1 dy. And once we integrate this, so pi times 5y plus y square by 2 minus 2, sorry, this is minus 4 and this is also minus 4 because we already have minus 2, so we can expand this. So then this is minus 4 over here, y plus 1 to the power 3 by 2 over 3 by 2, and then the limits are from 1 to negative. So then this is equal to pi times 5y plus y square by 2 minus 4 times 2 is 8 by 3 y plus 1 whole to the power 3 by 2 and minus 1 to 3. So now we need to apply the limit, so which is upper limit minus lower limit. So if we apply the upper limit, so we have to apply 3 into it. So for everything will y will replace with 3 and then minus, so 5 times 3 plus 3 square by 2 minus 8 by 3, 3 plus 1 3 by 2 minus 5 times minus 1 plus minus 1 squared by 2, and then minus 8 by 3, so minus 1 plus 1 to the power 3 by 2. And once we simplify this, so this will become 8 pi by 3. Okay, so this was our last question from this paper. Hope this paper is clear. Thanks for watching.